Lewis dot structures are models for molecules and polyatomic ions. As we have seen, a line represents two electrons being shared. The atoms of an element are represented by the elemental symbol, and dots represent unshared electrons. These unshared electrons are also called lone pair electrons. Drawing a Lewis dot structure is simply a matter of following the rules. Step 1 is to sum the valence electrons of all the atoms in the molecule. If the species is polyatomic, subtract electrons for a positive charge and add electrons for a negative charge. Step 2 is to draw a single line between the central atom and each outer atom. You can tell from the formula which atom is the central atom. It is the only element that appears as a single or one atom. If it isn't clear which element is the central atom, I will tell you. Each line that is drawn represents two shared electrons between two atoms. Thus, we have to subtract these shared electrons from our original valence electron total, which was calculated in step 1. That is step 3. If there are any electrons that remain after step 3, we must distribute these as lone pairs to satisfy the octet rule. We always start with the outer atoms first. When we draw a Lewis dot structure, nonmetals tend to have a characteristic number of bonding and lone pair electrons. Carbon tends to have 4 bonds, which are represented by lines. Since each line represents 2 electrons, we see that carbon with 4 bonds have 2, 4, 6, 8 electrons and fulfill the octet rule. Nitrogen atoms tend to have 3 bonds and 1 lone pair electron. We can see the octet rule is fulfilled: 2, 4, 6, 8. Oxygen atoms tend to have 2 bonds and 2 lone pairs. 2, 4, 6, 8 electrons. Octet rule is fulfilled. Halogens tend to have 3 lone pairs and 1 bond. 2, 4, 6, 8. Hydrogen is always an exception to the octet rule. Since it's in the first period, it can only accept 2 electrons, and hydrogen will always have 1 single bond.